Solving quadratic equations by using square roots. Before we get into that, first let's talk about how you take a square root of a fraction. We know that the square root of 4 equals 2 and that the square root of 9 can equal 3. They are perfect squares. But what happens if you have a fraction like 4/9 and you need to take the square root of that? Well, when you take the square root of that, you look at it and say, okay, it's not a perfect square, but actually it does break down into two perfect squares. We can take the square root of the top number, which is 2, and the square root of the bottom number, which is 3. So the square root of 4/9 would be 2/3. So that's something to keep in mind about how to take square roots from a fraction. And we're going to apply that a little bit later in this area of solving quadratic equations. So let's kind of take a look here. We want to remember that solving equations for the solutions are the same thing as calling the roots of the equation. So if we can remember that, because this is where the parabola crosses or sits or does not cross the x-axis. Remember, we're talking about a parabola. This parabola can be in several places. It can cross the axis in 2 places. It can sit right upon the axis like so, or it can be not even touching it. So we have different things that can be going on, so we could have different numbers of roots or solutions to our quadratic equation. Now, there are 5 different methods to solving quadratic equations. This just happens to be one of them, using square roots. And it only works because there will not be a bx term. If we remember that standard form for a quadratic is that we'll have an x squared term followed by an x term followed by an x to the 0 term, really, just the constant out here. We have these terms in this order, which gives us this quadratic. The square roots which give it to us. When we're solving by square roots, this term's going to be gone. So basically, we're going to be looking at a quadratic that's going to be centered on the y-axis, and it's either going to be moving up, down, or it may be upside down, things like that. So it's just going to be moving in this direction only. We're not going to be looking at things that move side to side. And because of that, we're allowed to use square roots to help us solve that, to find out exactly what number is it on the y-axis and kind of what's going on, so that we can figure out where it's sitting and what our roots of the equation are. So let's kind of take a look at something first. And we know when we look at something like x squared equals 25, we tend to think about, gee, what is numbers, or what are numbers that will fit that? Well, most of us will automatically come up with the number 5. But I'm going to show you that we can come up with another number, -5, because -5 times -5 is also 25. So let's think back a little bit to this. If you remember about fractional exponents. If I take the square root of something, so let's talk about the square root of x squared. At first look, this to you might be unreducible, but it actually is, because we know that a square root can also be denoted in fraction form as something to the 1/2 power. So basically what I'm going to take are the exponents of 1/2 and the exponent of 2, and I'm going to multiply those together. So x to the 2nd power times 1/2. And what happens is we can see that everything cancels. And when everything cancels, we end up having x to the 1st, which when we have x to the 1st, we can find our roots of our quadratic equation. So we're going to keep this in mind and what's happening here. So why is it -5 as well? Again, why are we thinking that? Well, let's put this in standard form. If I put this in standard form, I'd be subtracting 25 from both sides. I would get x squared minus 25 equals 0. So if we remember about the discussion I just had about how all the parabolas are on the y-axis, they're centered as their axis of symmetry is also here on this y-axis. This is saying that it's going to be sitting at -25. So if, let's say, this was -25, and since it's going upwards because of the positive a, this is going to be going to be hitting at 2 sides. Well, we know, like we said, we know that 5 goes in there because 5 squared is 25. So if this is 5 and the axis of symmetry is 5 away from that, that means that there has to be 5 away from the other side as well. So that's got to be -5. So there, that kind of proves why we have 5 and -5. I know when we talk about taking square roots of numbers, we always talk about what we call the principal square root. This is the principal square root, this 5. The -5 only talks about when we come into parabolas and solving equations. And usually, especially in the real world, our negative solutions don't apply. So let's kind of take a look at some things. Let's take a look at this. X squared equals 36. If we were to solve this, we would take the square root of both sides. And the square root of x squared is x, and the square root of 36 is 6. But because we know we're going to have two answers, we're going to get plus or minus 6. You'll notice that I'm stacking my signs, a positive and a negative. This is the easier way to do it, and this will come in handy later when we talk about the quadratic formula. Let's take a look at another example here. X squared equals 13. Again, if I take the square root of both sides, I will get x equals, and again, plus or minus, because I know I'm going to get two things. And what we want to do is take a look at why would we leave the square root of 13 as the square root of 13. And right now, if I was to get a calculator, right here, and I took the square root of 13, we can see it's not a perfect square. It goes on forever, kind of to pi. Just keeps on going and going and going. And since we can't be accurate with that, what we're going to do is we are going to not use it. What we're going to do is we're going to leave things as is. We're going to say the square root of 13. We're going to leave it that way. We'll talk about later how we can simplify that a little bit more, but we're going to leave it in what we call radical form. Radicals are what we use square roots with. Let's take a look at this one. X squared equals -4. If I take the square root of both sides, immediately comes to mind that, hey, square root of x squared is x. But what about taking the square root of -4? Can you take the square root of a negative number? In the real world, which is what Algebra 1 is about, you cannot do this. This is impossible. Since it's impossible, this would be considered no solution. Although, in the imaginary number system, we can solve that. That's represented by 2 times I, which is an imaginary number. Some imaginary number times 2 would make that happen. And this is more along the lines of Algebra 2. So right now we're talking Algebra 1. We wouldn't be looking at imaginary numbers. But this does have a solution down the road. And as you take higher math classes, you will get more number systems to look at. For now, we're going to say that if we take a square root of a negative number, we're going to have no solution. Now here's another reason, again, why is that true? Let's take a look at this. If I took this problem, x squared equals -4, and I added 4 to both sides, x squared plus 4 equals 0. So what is this telling me? This is telling me that I have a parabola, that again, it's centered on the y-axis, because there is no b, and it's going to be going up, and it's going to be going up at 4. There's that y-intercept. So because it's going up at 4, we can see it's never going to run into the x-axis, so that's why it's no solution. All right, let's get a little more complicated. Let's add some more things in there. And here you can see that the b is definitely missing. 6x squared minus 150 equals 0. So let's first start out by adding 150 to both sides. We do that, we end up with 6x squared equals 150. We're going to divide both sides by 6 and find out that x squared equals 25. Once again, we're going to take the square root of both sides. We do that, and we're going to get our answer of x equals plus or minus 5. A couple more examples for us to look through. This next one, 3x squared minus 20 equals -2. We're going to start out by adding 20 to both sides so that we can try and isolate that variable of x squared. And then we're going to get 3x squared equals 18. Then we're going to divide both sides by 3. X squared equals 18 divided by 3, which is 6. And then we're going to take the square root of both sides, and we're going to get x equals plus or minus the square root of 6. Once again, we're not going to be talking about that because if we were to look at a calculator, and we took the square root of 6, we'll get that crazy long number, and we really don't want that. So we're just going to leave it alone at this rate and not round to the nearest hundredth. Your textbook may ask you to do that, but for my class, we're just going to leave it this way. Let's look at one more problem. So I have x squared plus 16 equals 0. If I start to isolate that variable, and some of you may catch on already just by looking at it and thinking about what's happening. If I take the square root of both sides, yeah, the square root of x squared is x, but I cannot take the square root of 16. This is no solution. And again, if you want to understand what's happening, remember we're on a coordinate plane. Here we're looking at exactly what's going on. This is the y-intercept, and the y-intercept's at 16, and the a is 1. So there's a 1 out here. Because that's positive, that means it's going to go up. And again, we talked about how there's no b, so this axis of symmetry is centered right here. So we can see that there's not going to be any solution. So hopefully this will help you using solving by square roots. But remember, this method only works when there is no b term.